Today we will discuss the second phase of business probabilities, uh, probability distribution for management students. We will discuss this. And in the last class, we have discussed some of the basic concepts of probability and some probability laws, such as addition rule, and multiplication rule, conditional probability, and mutual exclusive events, independent events, such things we have discussed. Here we will do some calculations. Uh, we move to next step in the probability distribution. Probability begins with what we already know, right? So when we toss a coin, we know the probability, right? Either for obtaining the head, we know the probability. Before we toss the coin, we already know the 50% chance. When we throw 6-faced dice, we know that each score having 1/6. So we know the probability. Probability begins with what we already know. Here, example 1 is mentioned, tossing a 6-sided die. So you may see, you know that 6-faced die has 6 scores. When we throw, the probability is this. This is equally like each outcomes has equal chance or equal probability. We already know, right? Before we throw the dice, we know the probability of each score. And when we toss a fair coin twice, 2 times, we know this, we can draw in the tree diagram, head, tail. We know that uh, 1, 2, right, 1 of 2. And this is first outcome. Second outcome, the possibilities, head, tail, head, tail, each 1/2. And when we toss this coin sequentially or 2 times, what are the outcomes? HH, head and head, or head and tail, or tail, head, and tail, tail. Here are the probabilities, right? 1/2, 1 into 1/2. We know that probability is 1/4. This is 1/4, 1/4, 1/4. So we discussed this one in detail in the previous lectures. Now we see when we make a table, right? Table, the output, right? The outcome and probability. When we make a table, outcome, 1 head or 0 head, right? Outcome, the head, right? We are considering only head. 0 head, 1 head, 2 head. So these are the possible outcomes of head. Possible outcome for obtaining head when we toss a coin twice. So these are the possible outcomes for head with regard to head. What's the probability of heading? What's the probability of obtaining 0 head? With no head. So where is it? Here, right? Here in this outcome we have no head. So 0. Head equals 0. What's the probability? 1/4. Second, the probability of getting at least one head, probability of getting at least one head, not at least, exactly one head, right? Exactly one head. So here we can get at least one head, here exactly one head. So therefore 1/4 plus 1/4, we can get 2/4. That could be 1/2. Right? So how we get 1/4 plus 1/4, one head. And here the second, we get exactly 2 heads, exactly 2 heads, the probability is 1 over 4. So this is the probability distribution. Probability distribution. Here, the probability distribution table, we place the we decide outcome and their probability. So this is called x, and this is probability of x simply. And so when we take this result total, what is the total here? So we can make it 4 over 2, right? Then 4 all in denominator are same. 1 plus 2 plus 1, 4. This means 1. Here, the sum of probabilities, sum of all probabilities, sum of probabilities of the outcome of x is equal to 1. So it's mean that um, the sum of probability, sum of probability of any random variable is equal to 1. Always should be equal to 1. That's a thing we have to keep remember in our mind. Right, the same the picture, the example to illustrate the thing what I explained now. Tossing a fair coin twice, exactly 0 head, the probability is 1 over 4. Getting exactly 1 head, the probability is 1 over 2, and getting exactly 2 heads is 1 over 4. So this is just a reminder. Now I introduce a new rule of probability distribution, the universal rule of probability distribution. It always should be true. Right here, as the previous example, we throw 6-face dice here, 6-face die, and we here in this table we toss 2 coins simultaneously or sequentially. The scores, what are the scores here? We will get the score 1, 2, 3, 4, 5, 6. And the probabilities, right? 1 over 6, 1 over how we got 1 over 6. And this table, the possible outcome of head, 0, no head, 1 head, and exactly 2 head. Here exactly 1 head, exactly 2 head, the probability is here. When you look at here in a probability distribution, so this is probability distribution, right? This is probability distribution table. In the probability distribution, the sum of all probabilities should be exactly 1, not less or not higher. Exactly, it should be sum of the total of all probabilities should be equal to 1. This is the universal rule for any probability distribution. Now let me introduce a new concept called random variable. Random variable, random. You might experience this kind of trial experiment, and we don't know when we select, right, a ball from this basket, we don't know what value we are going to get, right? So the score we get from this kind of experiment or any events, any trial, it's called random, right? The value here, there are many numbers inside the basket. Here we get either 2, 4, 5, like 3, like that. These values we obtained on chance, purely on chance. The chance dictate the outcome. The chance predict the outcome. When the occurrence of values, right? This is the occurrence. When the occurrence of values in a variable is governed by chance, The variable is known as random variable, right? When the occurrence of values in a variable is governed by a chance, the variable is known as a random variable. Here, when you throw a die, six-face die, you may get scores range from 1 to 6. But the score we are getting from that trial, it's governed by chance. So therefore, that is random variable. Obtain a score from throwing a dice. It's what? It's a random variable. And when we toss a coin, we get the outcome, head or tail. It's governed by chance. So that is random variable. A machine produces some goods. There are possibilities of getting good goods, good items, and defective items. The producing defective items is based on the chance. We don't know which item is going to be damaged, defective. Here are two distinct type of random variable. Now you understood what do you mean by a random variable? Random, it's by chance. Random, if you don't mind, we can name it chance. Chance variable, random variable, right? The value is totally defined by the chance. Here there are two kind of random variable. One is discrete random values. Assume only some specific values or predefined specific values. And continuous random variable, now you can see it can assume any values for a simple event of a sample space. Example, measuring the length of iron rod. Right. So here, to explain this, you take this six-face dice. You know that when we throw this, we can get the specific values that range from 1 to 6. All of them are 1 or 2 or 3 or 4 or 5 or 6. When you throw a coin, when you toss a coin, you may get head or tail. These are the specific values. These are specific values. Already we know what are the possible outcomes. But here, the continuous random variable here, it may get any values from sample space. Here, for example, in an examination, you got 0 to 100 marks range. It get any values, say 1, you may get 1, or 90, or 90.6, 90.99, or you may get 76.02. Right? Here we can't define how many outcomes between these. Here, when you look at here, we have already specific numbers, only 6 outcomes. Here, 2 outcomes. Right, specific values. But here we couldn't define any specific value. Here, even from 0 to 1, right? How many values are there? Some people says 0.1, 0.2, 0.3. Some people write 0.0001, 0.00000009, right? It's within this range, but we don't know what is specific value. But it assume any values, can assume any values for simple event of a sample space. Example, measuring the length of the iron rods. Right? Here a machine produces an iron rods. Right? The length of this iron rod can be measurable using a tape. Measurable, sometimes it may be 20.2 feet, sometimes 20.001 feet, or sometimes 15 feet. Right? So it's measurable. Likewise, height of a student, height of a man, it takes any values. sometimes 3 feet, 3.2 feet, 5 feet, 5.5, 5.8, 6.1, 6.2, 6.5, or 6.025. So it take any values within that range. So that is what continuous random variable. The major difference is the discrete variable is already it does only the specific values, but here it takes any value, that is continuous random variable. So this understanding is very important. In the forthcoming lectures, we will discuss binomial distribution, Poisson distribution, normal distribution, unified distribution, right? There are many things we will discuss. So those are this distinction is very important for understanding such in-depth analysis of probabilities. And the two axioms you must memorize. Always you should memorize. Don't forget, right? When you are dealing with probability distribution. For a discrete, as we discuss here, for a discrete probability function, where x takes values either x1, x2, or it's up to xn. So like when we throw a dice, six-face die, it may take 1, 2, 3, right up to 6. With the probabilities, probability of x1, probability of x2, probability of xn, right? Here, what's the probability of getting score 1? 1 over 6. What's the probability of getting 2? 1 over 6. 1 over 6. Like that. We have so each outcome has its own probability. In this example, all probability functions, the probability equal to 0, but it's not always true to follow the discrete probability function. Right? Not necessary to be equally likely, not necessary. The thing is, the probabilities can never be negative. Probability, as I told you in the earlier sessions, the probability range from 0 to 1 inclusive probability, right? Probability, right? Equal to 0, more or equal to 0, and uh, less than or equal to 1. Probabilities can be never negative, so we can express in this notation probability of variable x, probability of variable x should be equal or more than 0. So it cannot be negative. The probability of any variable cannot be negative, like we can't write 0.01, negative 0.002, we can't write. So no probabilities with negative values. And the sum, right, the total of probability of any variable must be equal to 1. Total sum of the probability is equal to 1. The sum of all probabilities must exactly 1, not less or no more. And we will start to learn how do we calculate the mean and mean, variance, and standard deviation of any probability distribution. Here, the main formula here, the mean. So here the mu, right? So mu. Mu means the average. In the previous studies, we may use this term, right? X bar. Mu, sometimes we write in X bar. X bar we use for what? Mean or average. Average probability, right? What's the average probability? If you don't mind, we can say like that. Or a mean probability. The mean or expected value. Why do we use the term expected? Here, when we discuss mean and standard deviation for a probability, not probability, distribution, right? Frequency distribution or any things from the beginning. We studied what, right? Mean equal sigma x over n, and the x value has given, somehow x value are given in a table format or any other form. Here x values 2, 3, 5, 7, right? So and we take the total of this and we divide by number of observation, 1, 2, 3, 4, right? So in this case 2, 3 equal 5, 5, 5, 10, 10, 17, 17 divided by 4. This is the mean. But here the probability, the events are not occurred. We don't know the outcome, but we just predict. We expect. So that's why we call them expected values. So there are different probable. There are different chances for getting a specific result. The specific result having the own probability, the chance. Then the average of the values, expected values, it called as a mean. So mean means expected values, average of expected values. It write here the notation, the mu, right? The mu refers the average equal expected. E mean expected value of x, expected value of variable x. It can be calculated like this: x over, right, x into probability of x. This is the simple formula, and we take the total of this. So that is the mean. But normally, how calculate? Sigma mean equals sigma x over sigma x divided by n. But here we multiply x values into probability of x. When we do in a numerical example, it's easy. Understanding this thing is very easy. The sum it all of what? This area. Here x mean what? The value of the variable, and here the probability of the variable x. To find the mean, simply multiply each values by its probability, then add all them all together. It's very simple. And the second base we'll discuss anatomy of formula. Here variance and standard deviation. Variance and standard deviation. Here this is the term, this is the symbol we use to express variance. Yeah, variance equal. Yeah, there are terms here. X square multiplied by probability of x minus square of mean. Square of mean. Here, the multiply the square value. Squared value. This is the value, no? This is the value of x, and we have to take the square by its probability. This is the probability, right? And it's total of that. Total of this, and the second part we here deduct from this total the average, square of average, subtract the squared mean calculated in the previous step. Here we calculated, no, here we have calculated the mean, and we have to take the square here. Then we can calculate variance. The standard deviation, we know that square root of variance, we call them as standard deviation. Now we studied the formulas. Now we will work on an example. Right. When you sit for the exam, each semester, students can expect what is the GPA in the forthcoming or the current semester examination. Right. What will the GPA for a particular subject? you may, right? These are the possible results, the possible grades. Either you can get A or B or C or D or E. At a time, you can get only one. If you get A, your GPA 4. If you score B, GPA 3. If you score C, GPA equal 2. If you score D, your GPA equal to 1. If you score E, the score the 0. The point is 0. Now, based on your experience and based on the hardness or easiness of the exam we have written, the probability of getting grade A is only 12%. Probability of getting B is 32%. Probability of C 38%. Probability of D 0.15. Probability of E 0.03, means 3%, 15%, 38%, 32%, 12%. When you add together, right, it should be equal to 1. Otherwise, right, the question is wrong. Right, the sum of probability of x should be equal to 1. Let's check. 2 plus 2, 4, 12, right, 0, and 1, 2, 5, 8, okay, it's equal to, right, 1%, right? It means 100%. It should be sum of total probability is equal to 100%. Now let's see. Now somebody asked what the expected GPA this time you will get. What is your GPA you may get? Now you know the probability of getting A, B, C, and you can guess based on this assessment, based on this assignment of probability of each score. You can say uh, the expected GPA for this exam, for this subject, could be how we have to find out the average. We have to find out the mean. What's the formula to calculate the mean? It's very simple. X, right? Value of x into, right, into probability of x. Now we know the values of x. What's x? So these are the x. 4, 3, 2, 1, 0, right? And probability of obtaining 4. What is that? 12%. Simply 4 into 0.12. So that is the value here. And likewise 3, x value 3 into 0.32. So likewise we have to calculate for 2, 1, 0. For all x's we have to multiply the probabilities, and we have to take the values, and if we take the sum of all of these, then that is equal to the mean. So that you can say my expected GPA for the subject is like this. Here, workout example, building a calculation. First, you have to prepare a table. That table should contain value of x, the variable x, and probability of that variable x. Here for 12%, like that it has been written. And now x multiply by probability of x. Here 4 into 12%, 4 into 0.12, you may get 0.48. 3 into 0.32, you may get 96. Likewise, you may get the score when we take all the values, sum of all these values, it's equal to 2.35. Then what does it mean? Now you can simply say, in this exam for this subject, I can score on average 2.35. My GPA, my expected GPA is 2.35. Expected, right? You should remember, it is forecast, it's a predicted 2.35. Once you got the result, right? After you get the result, no need to calculate the probability. Why? If you got A in a particular subject, then your GPA is 4. Already happened. So you don't need to calculate. I guess the chance after getting the result in your hand. So no point of expecting, guessing, right? So it's certain. It's happened. Then 4 into 1, 4. Your GPA 4. If you get result 4, if you get result A, your GPA 4. If you get result B, your GPA is 3. But your result is not yet released. But based on your satisfaction on the examination on the paper, you may guess. So, and for getting A, this chance, this chance, this chance, then on average, we can say on average 2.35. 2.35 mean where? Somewhere here. Somewhere here. This is A, B, C, D, E. Then you expect, right? You expect between between B and C. B and C, since you are getting 2.35. 2.35 is here now, in this range. In this range. So that's the meaning. And expand in the table to find out the standard deviation, right? When you look at the formula of calculating the variance, we should know x. So x square. So this is we have value of x. Value of x we know. Then we just get the square of this x square. X square, and probability of that is given. And we already calculated the mean, and we take square of that value. Here we prepare a table, right? We already prepared this one, and we have to add this. Newly we have to add this. How do you calculate this column of the table? Here x square, 4 by 4, right? 4 into 4, 4 by 4. Then probability of x 0.12, 0.12. Then we will get 1.96. Likewise, this is easy, right? 1 into 1 equal 1 into 0.15 equal what? 0.15. And here 0 into 0, 0 into 0.30 equals 0, right? Likewise, 2 into 2 equal 4, right? 2 into 2 equal 4 into 0.38, that is 1.56. Now, can you calculate this one, value of this? How calculate this value? 3, right? 3, x is 3. So we have to take the square of 3, then 3 into 3 into 0.38. Tell me what's the value? What's the value of this? 9 into 0.38. Sorry, yes, 3.2, no? 3.2. 3.2, not 3.8, 3.2. What's the value? 3 into 3 into 0.32. What's the value? Yes, yeah. The value is, yes, 3 point, not like that.
2.88.
Yes, 2.88. Yes, 2.88. Right. So the likewise, it calculated. Now we have to take the total of this column. We have to take the total, and it's equal to 6.47. So we have calculated this part. We calculated this portion. So that is equal to 6.47. And the second part, we already know the mean. The mean is 2.35, right? 2.35. and we have to take the square of that, 2.35, and square of this. And here we calculate the variance equal 6.47 into minus 5.52 equal 0.95. So this is variance. This is variance, and we know that standard deviation is equal to square root of variance. So that is square root of 95 equal 0.97. Right? Clear? Is it clear? Is it clear?
Yes, sir.
Okay. Now we move the exam type of questions. Exam type questions. Then here value of x is given like this. A value of x, a discrete random variable. Discrete random variable mean it provide only a specific values. The variable may get value -2 or -1, 0, 1, 2, 3. This is the values. So since it's a discrete random variable, there are no chances of getting 0.05 or 0. Or 2.25. No chance, because it has predefined specific values. So the value of x -2, right, from -2 to 3, and probability of x mean probability of getting -2 is k. Probability of getting value score 0 is 2k. Probability of getting score 3, where x equal 3 equal 5k. Then, right, then the question is determine the value of constant k. So what's the value of k? So what the rule we have to use? K is unknown. How we can calculate the value of k? What's the rule? The rule is, that the probability sum of probability x equal what? Equal to 1. You have to remember probability of any variable, sum of probability of any variable equal always exactly 1. So these are the possible outcomes. These are the possible outcomes, and these are the expectations, the chances. We know that sum of all these values equal to 1. So therefore here only one unknown. What is unknown? K. So k, right, all together it's equal to 1, no? Then how many k is k? 2k plus 2k plus 3k 4k equal how many? There has to be 14 k's. This is a golden rule, right? Sum of probability of x equal 1. Using the golden rule to solve for k, right? K, right here, k, 2k, 2k, 3k, 4k, 5k equal 1. Then how many k's? 17 k's. 17k equal 1. Then k equal 1 over 17. K equal 1 over 17. Now we hold the key to unlock the rest of the problem. So k equal 1 over 17. If you have 2k, so its value is what? 2 into 1 over 17. If it is 3k, very simple, 3 into 1 over 17. Right, now we can substitute. Here the k mean 1 over 17. 1 over 17. Here 2 over 17. Here 2 over 17. 3 over 17. 4 over 17. And 5 over 17. When you add all these together, you should get exactly 1. Let us test it. Here all denominator are equal. Then we can numerator 1 plus 2 equal 3, 3, 5, 8, 12, 17. 17 divided by 17 equal 1, right? So we correctly found the value of x, value of k. The second question, find 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 the probability of x, right? Probability of x that take value less than 2, right? Find the probability of x, the x value take values cause less than 2. So what it covers? Less than 2, not equal sign. Very careful. Carefully look at here. There is no equal sign. So that without 2. But it should be less than 2. So it covers, what are the? It covers this value, this value, this value, this value, because it is less than 2. Then how much? That's the, what's the probability of that? Sum of these values. Right, 1 over 17 plus 2 over 17 plus 2 over 17 plus 3 over 17. Then how much? 1 comma 2 3 3 5 8, right? So simply the answer could be 8 over 17. Probability of x that is less than 2, here less than 2. Then here very simply we found. Second part of that second question, find the probability of x. Find the probability of x that takes values from this range. It should be 2 or less than 2 and, right, and more than minus 2. So we can't take this value. More than minus 2, not equal. Here more than minus 2, we can't take this, and including 2. So here we can take, we can, right, we can take these values. It includes, right, this value, this value, this value, and this value. So here, yeah, 2, right, 2 plus 2, 4, 4 plus 3, 7, 7, it should be 11, right? 11 over 17. 11 over 17. Let's check the answer. Yes, 11 over 17. Now we calculate the mean, right? Mean and standard deviation. Next question, find the mean and standard deviation of this distribution. For that, what we have to do? What we should do? Simply, we have to prepare a table, value of x and probability of x. So what are the values it takes? Yeah, it takes minus 2, minus 1, 0, 0, 1, 2, 3. Then probability, we know that probability here k mean, what is that k? 1 over 17. And minus 2, 2 over 17. 0, 2 over 17. 1, 3 over 17. 2, 4 over 17. And 3, 5 over 17. And the sum of this probability of x always equal to 1, exactly 1. Then what the formula to calculate the mean? Oh, right, what's the value? What the formula? Very simple, x into px, and we take the sum. Right, now we create another column, x into px. Very simple. Here 2 into 1 over 17 minus 2 over 17, and minus 2 over 17, here minus 2 over 17, and it should be 0, and 3 over 17, like that we can get, so that finally we will get the sum, the total will be the expected value or mean. It already done somewhere here, right? So if you wish, I can do it in the Excel, but it's basic, no? So when we do that, um, we can get 1.29. So if you want, so I will do it in Excel. So I can share my screen. Here, for P, right? So value of X, we take X and the probability P. And here -2, -1, 0, 1, 2, 3. And the probabilities 1 over 17, no? 1 over 17. 1 over 17, sorry, 1 over, and this also 1 over 17, and yeah, 0, 2 over 17, sorry, this is 2 over 17, no? 2 over 17, and this also 2 over 17, and this is 3 over 17, and 4 17, and 5 17. Right, so here it should be equal to 1. You need to verify this. Yes, exactly 1. Now, to find out the mean, we should get x into px or x into p, right? Here, very simple, 2 into p equal this value. Likewise, we take all here and right, sum of this, it's equal 1.29, right? It's the mean equal 1.29. Next we will find the variance and standard deviation. The formula, we know that x bar, right? The formula to find the variance equal x bar into sigma, what do you call it? I take this here, yeah, it's here, px sigma. I take the screenshot of this, it's easy for you. Right, this is, sorry, sigma x square into px minus x square, right? So this is the formula. Then here we know that we know x square. According to the formula, we should know x square. We already know the value of x. Then we have to take x square. Now I take here x square. Very simple. This value into the same value. Then we will get x square. And then we have to multiply this value. We have to take multiply this value with px probability p. Simple. Here this value into p, probability of x. Then take all this together and we will get the sum. This is at 4.1778. So we get this value. We have obtained this part, right? This part equal 4.11765. Then we already calculated x bar scar. We know x bar, so that is 1.29. This part is 1.29, and we have to take the square of this. Then let's see. Let's work continuously. Now variance equal, this value minus, and we have to take the square of this value. So the variance equal 2.44, and the standard deviation should be square root of this, then 1.56. Let's check the answer. Yes, yeah, we got the same exact answer here. Yeah, mean equal 1.29. Here we also get 1.29 here and 1.29, and the variance is 2.44. Here also we get 2.44, and the standard deviation is 1.56. 1.5. This is the way of doing calculating mean and standard deviation of any probability distribution, especially in their discrete random distribution. Right. Now we come to the final slide of this session. The ultimate business start cheat sheets, the summary, the definition, the random variable means the variable, the outcome is governed by chance. Discrete mean it takes only specific values. And there are two types, right? Discrete random variable and continuous random variable. Continuous means measured value. It take any value between a particular range, any value in the range. But the specific value, it's already defined. What are the values? And formula to calculate the mean equal sigma, right? Total of x into a probability. Variance simply the sum of x square p minus x square, and standard deviation square root of variance. And remember always, the probability of any variable never be negative and not exceed 1, and it should be exactly equal to 1, exactly to 1. And when you prepare to answer in the examination, right, the x value is given. Sometime you may need to calculate the probability of x, so based on the constant terms, or sometimes they may give you directly. And then to find out the mean, you have to calculate, you can just multiply these two. Therefore you need to prepare this column. And to calculate the mean or variance or standard deviation, you should know, right, you can directly take the square of this x value and multiply this, and you can fill this column, or else you can add one more column that represents x square, and then you can add this column. That's all about today's session. If you have any doubt, you can ask any questions.